Today we're going to be explaining Pythagorean's theorem, which you can see here. A squared plus b squared equals c squared. In the real life example, we would use this to find the missing side length of a triangle when c would be our hypotenuse, as seen here. Therefore, once you square these, they should equal out to this.
So for example, if A was to equal 3 and C was to equal 5, we'll just plug those into the formula to find our B, which will be 3 squared plus B squared equals 5 squared. So that'll be 9 plus B squared equals 25. Subtract 9. It'll be B squared equals 16. After that, you'll square root it both sides, and then B will equal 4. And that'll be your answer. So to further elaborate on why a squared plus b squared equals c squared work, we'll add another right triangle right here. This will be our B, A, C. Add another one right here. And then our last triangle will be here. And then, so from here,
To further elaborate on what Ellie said, we want to find the area of this outside square, of which there are two ways to do so. The first way would be taking the base, multiplying that by the height, looking like so. We have our AB twice, therefore b squared. The second way to do so would be taking the inside of this square right here and adding it to these four triangles, looking like this.
So out of all of this, we can say that this is equal to this. So we can create an equation from that. So what we can write is a plus b squared is equal to c squared plus 4 triangles times the area of a triangle. A, B, 1/2. Okay? So from here we just have to do simple algebra. So on this right side, we can just say that c squared will stay as c squared plus, when we multiply AB in 1/2, you get AB over 2. You have to multiply that by 4. You can actually reduce or simplify this down to a 2. So c squared plus 2ab. Now that's for your right side. Your left side, a plus b times a plus b, which equals a squared plus 2ab plus b squared. And what you do here is just all you do is distribute, use the distributive property. And that's simple algebra, and if you're sitting there and you don't know how to do that, then you probably shouldn't be in this class. But if you you know what I'm saying? But if you want an explanation of how I did that distributive property, it's very simple. Just imagine two rectangles, same height. You got the same height. A. Length is different. B. One of them is C. Okay? To find the area of this rectangle, what do? You do your base times your height. A times B, right? Same thing here. How do you find the area? A times C. So, let's say if we added those rectangles together, what would happen? Well, you would have one big rectangle with two different parts. One is B, one is C. The height is the same, which is A. And now you want to find the area of that. It kind of goes back to our original square. How do you find the area of that? Well, A times, what is this doing? Adding B plus C. So how would you multiply this out? Go back to your first square. What did you do? You multiplied A by B, right? You multiplied this A by C. That's what you do, distribute. So when you have A plus B times A plus B, that's all you're doing. Distribute it out. Take the second one, distribute it out. And that's how you get your A squared plus 2AB plus B squared. Right? A squared plus 2AB plus C squared. On our right, no, not C squared, B squared. Alright? And our right side, which I erased, but our right side was, it was,
C squared plus 2AB.
yeah, help from the audience member. C squared plus 2AB. Ultimately, what happens? 2AB gets canceled. A squared plus B squared equals C squared. So that's the derivative of how we get this formula. That's where it comes from. It's specifically designed to equal out. So it goes back to such things as Pythagorean triples, which was mentioned earlier in the video. 3 squared plus 4 squared equals 5 squared. Now we proved why Pythagorean triples always work and why this theorem always works on a right triangle. The A and B squared always equal to the C squared. The same theorem has been used in things like the, what's it called? Pythagorean, what's it called, man? Pythagorean, sine squared plus cosine squared identity.
Pythagorean identity.
Right, the Pythagorean identity goes off the same basis. So does the distance formula. This formula is simple and it's easily proven, but it's used in much more complicated things. If you think about your Pythagorean identity, you have your theta right here. What is this? This is your cosine of theta. This is your y value, right? Theta. So you pretty much have your x here, you have your y here. We can say the same thing. We have your a here, you have your b here. The radius is 1, right? What's the Pythagorean theorem? Squared, squared, squared. That's why it even works on the Pythagorean identity. Cosine squared plus sine squared, these are thetas, equals 1 squared, which is 1. That's another example. And even this, like I said, was derived from the distance formula. The distance formula, finding a point from here to here, is based on using this same concept of a right triangle. So this goes way deeper than just a simple a squared plus b squared equals c squared. So I hope some of that made sense.